Hey guys, sorry for not having this out on Monday. I made a video on Monday from the Google Meet that I did with some students, but I wasn't happy with the recording settings I had at the moment, so I just need to make a new one, and so here we are. Okay, so first off, polar coordinates 6.3. What I'd like to do is just kind of do an introduction over this, over the next couple days with just like what polar coordinates are and the functions and how to convert and how to write them, how to find them, and then we'll just come back to it if you take Cal 2, and then we'll talk about it at the very end of Cal 2 or BC Cal. Okay, so one thing you need to know is like, in the Cartesian plane, you have an x and you have a y coordinate. So you go like say 3 on the x and 4 on the y, and that coordinate point is the point 3, 4. Well, as far as polar goes, another way of defining a point is using this ray right here, or this, well, I could say ray, but we're going to go ahead and say this segment, I guess, going here. And you could say, okay, go this distance, right? So if this is a 3, 4, this would be 5, right? And then it would say at this angle. And so we could say 5 at whatever angle that would have to be, and we could find that using right triangle trig, right? So I could say if tangent of theta is opposite over adjacent, so 4/3, then theta equals tan inverse of that. So if I want that in degrees, I'm going to go mode. And this is not something I would expect you to do. We're going to talk in the degrees that we know, the ones that we use all the time, but I just want to go ahead and, like, since I did this example, I might as well. So we're going to take tan inverse of 4/3, and we get 53.130. So that would be 53.130 degrees. So then we could say, okay, go out 5 units at 53.130 degrees. And then that would be your coordinate point in polar. And so what it is this a radius and an angle. So in the Cartesian plane, you have x and y. In the polar plane, you have r and theta, a radius and an angle. Okay? So it's, if I told you to travel or go to the point, plot the point, let's go 2 and 120 degrees, right? So we would, x and y, 120 degrees is in here, right? So you would go out 2 units and think, okay, out on the circle, I'm just going to do this real quick. So if I had a circle with radius 2, then I would say, okay, it's going to be right here because it's out 2 units, right? So we now have circles with like 1 and then 2 and then 3 and then 4, right? As opposed to just down and then up, right? So we would say go out 2 units at an angle of 120 degrees. I tend to go the angle first, go 120 degrees, and then go out 2, just because it's easier for me to graph it that way. But it's whatever you see. Okay, so polar coordinates, big thing is r theta versus the xy. Okay, oh, as far as like when do we use polar coordinates, they use them in navigation because it makes sense to think about like go at this angle this many miles or nautical miles or whatever. And then like as far as using polar equations, because we're going to get into polar functions today and then polar equations, well I guess I converting today and talking about them a little bit, but then actually graphing them and whatnot either tomorrow or Friday. So, but those are definitely used for things in physics where the range of motion is circular or it's orbital or it does something where you're backtracking. Because doing this r and theta allows you to have different kinds of graphs. So you're going to see some very interesting graphs, things that would not be functions in the Cartesian plane. Okay? All right, here we go. I just said that, so we're good. Well, I didn't say exactly, but I just drew it. Okay. All right. Okay. Again, it says, O is the origin and the pole, and x-axis the polar axis. A point is ID'd by the polar coordinates r theta. The directed distance is the absolute value of r. Okay, so this is very important because we can actually have a negative r, and we'll talk about that in a minute what that means. Okay, although you might think about what a negative radius would mean. And then theta is the directed angle. And just like in the unit circle, we can have negative angles. It just means go in the opposite direction, right? So then, one thing I do want to remind us of is the unit circle, just to remind ourselves before we, oh yeah, let's remember our radians. Okay. Uh, you do not need to necessarily draw this out in your notes, but if you wanted to, and if you're like, I remember it all, it's fine, then you can skip ahead until I get to the next thing. But it might not be a bad idea for you to have your unit circle with you. So if you want to get that out of your notes, then I wouldn't. That wouldn't be a bad idea. Or we can just sit and recreate it right quick, okay? So, you know, we all have the ones in the very center, and then we have splitting it into thirds, right? So 15 away, and then 15 and 30 away from each other. Okay, so just a reminder, we've got 0 degrees and 0 radians, right? We've got 30 degrees. I'll go ahead and do the degrees right quick. 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270, 300, 315, 330, and 360. And anything greater than that is more than one rotation. It puts you right back in the same spot as this angle between 0 and 360. Okay? Then, if we think of these in terms of radians, we've got 0, we've got 2 pi, and we've got pi. Yeah? Go ahead and put that in purple. Okay. Then, if this is pi, or just remember this is half pi, so 1 half, 2 half, this is 3 halves pi. And then we can think in terms of 30-degree arcs. There are 1, 2, 3, 4, 5, 6 30-degree arcs between 0 and 180. So this is 1/6, right? Or pi over 6. This is 2/6, which is 1/3 pi. 3/6, which we've already got, is 1/2. 4/6, which is 2/3 pi. 5/6, which doesn't simplify. And then it just keeps on going, right? So pi, and then 7/6, 8/6, which is 4/3. Yeah, dadgummit. 9/6, 10/6, which is 5/3, and 11/6 pi. And then you have your quarters, right? So there are 4 45-degree arcs. 1, 2, 3, 4 between 0 and 180, or 0 and pi, which means this is 1/4 pi. So just as a reminder, 2/4, 3/4 pi, 4/4, 5/4, 6/4, and 7/4. Well, and 8/4, but there you go. All right, so just as a reminder, and if we need to come back to that, we will, but, you know, 180 pi, 362 pi, stuff like that, okay? All right, so we're going to graph this. Now, I have a polar coordinate axis on my notes, but you don't, so what I'm going to do is I'm going to draw one with you, because I want you to have that in your notes, something similar. Okay, so I'm actually going to change one of these points so that you don't have to go as far out. Let's make this a 3. Okay, so if you want to pause and write these points down, cool. If you, just wait a second, we're going to draw kind of together anyway. So what I want you to do is draw an X and a Y. Well, you know, not an X and a Y now. It's a radius. You got your, oh, what'd they call it? Lord, no, oh, it's on this page. The polar axis is the x-axis. Okay, and it's just all rotations of the same. So what I want you to do is go out, let's say 5 is the most, let's go out 5 and give yourself a little bit of space. 3, 4, 5, and try and keep it the same scale. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And as best you can, try and create circles using the dashes. So this represents the different radii that we can go out. And then I'm going to have you do another thing. So for the angles that we generally need to know, let's go and create those. I'm going to use a post-it. Okay. So I'm going to do the one in the very center. So we haven't graphed anything yet. We're just drawing our plane right now. Let's do 60 degrees and, well, that's not quite. That's more like half. Oops, sorry. Oh well, I mean, as close as you can get to what it should be like. And please do take the time to draw this into your notes so that you can have a good example of it. And we will just try and do this once and then draw on this grid. Oh, this is going to be interesting. Oh, I need it over here. Okay. Something like this. And then we'll do it again in here. So in the very center, for the 45. And then, and you don't have to be using a straight edge. Okay. So maybe pause it until you have that drawn, and then we'll start sketching our coordinate points, okay? So in your notes, I hope you have that drawn, and first let's label point A. We're going to write it down, and then we're going to graph it. So that means we have a radius of 4 units and an angle of 60 degrees. So we know that this is 60 degrees, and we're going to go out, we're going to go 60 degrees and then out 4 units. So 1, 2, 3, 4. So this coordinate point right here would be A. So let's draw it and label it. Okay. Now let's talk about what this says. So the coordinate point 5, negative 2 pi over 3. So let's just remind ourselves first of where 2 pi over 3 is. 2/3 pi, and remember, if you don't remember the exact radians right quick, you can just say, well, I know that pi is 180 degrees, so 180 divided by 3 is 60, and 60 times 2 is 120. So 2 pi over 3 is the same thing as 120 degrees, which is right here. So 2 pi over 3 is right there, but that means 120 degrees, so it's this direction, 90 plus another 30, right? Or a full half pi plus another portion. So what we're going to do is we're a sixth. We're going to go backwards 2 pi over 3, which puts me at 240. Yeah? Or 5 pi over 6. No, 5 pi over 6 is over there. 5 pi over 4 pi over 3. Not 5 pi over 3. And 5. So if we go negative 2 pi over 3, and then out a radius of 5, so 1, 2, 3, 4, 5, that puts me right here, and so that is coordinate point B. Okay. Next we've got, okay. We're going to do the coordinate point B. So, or sorry, C. C is negative 3, 5 pi over 6. Okay, so this is a little bit different. It's got a negative radius. So 5 pi over 6 is right here. 5, 6 pi. And then negative 3 means we're going to go a radius of negative 3. So normally I would say go here and then go a radius of 3, 1, 2, 3. But because it's a negative radius, what you actually do is you go across and go 1, 2, 3. Notice how that is not the same thing as going negative 5 pi over 6. Negative 5 pi over 6 would put me right here. Negative the radius flips me across the origin, across the pole. So 5 pi over 6, negative 3 means go in the opposite direction, 1, 2, 3. And so that would be coordinate point C. All right. And then coordinate point D is negative 2, negative pi over 3. So like I said, I always like to go for the angle first. So I'm going to go negative pi over 3. So pi over 3 is right here, right? Negative pi over 3 means go backwards 60 degrees, or go backwards a third pi. And then negative 2 means have a negative radius, so that would actually be, normally I'd be here, but then it pops me across 1, 2, and I'll be right there. Okay? So, positive radius, positive theta, go exactly where it says to go. Positive radius but negative theta, just go the reverse direction in an angle, but then stay on that radius. And then a negative radius means go across the pole to the other side. Okay. What I want to do now, I have these on here. What I want you to do is go ahead and change that to E, F, G, and H. E, F, G, and H. I'd like you to pause the video, and I'd like you to write these down and plot them on your grid, and then play it, and then you can match it up and see if your points are in the same place as mine. Okay. So for E, negative 30 degrees and 5 units, right? I did have negative 7. Let's make that a negative 4. Okay. All right, so what we can do, give me a second. Okay. I'm going to go negative 30 degrees, right here, because this is 30 degrees. So this would be negative 30 degrees, and then a radius of 5, which puts me 1, 2, 3, 4, 5. And that would be E. Oop. Okay. F is at the coordinate point 2 and 2 pi over 9. So 2 pi over 9 is not on my unit circle as far as like one of the main ones I know, but we can always convert. 2 pi over 9, pi is 180 degrees. Now I'm just doing replacing. Remember, you can also convert. 2 pi over 9 radians times, and if you want to undo the, if you want to change your unit to degrees, you multiply by the unit. 180 degrees is equivalent to pi radians, the unit conversion. Pi radian simplifies out. 2 times 180 divided by 9, or 180 divided by 9 is 20, and 20 times 2 is 40 degrees. So we are at 40 degrees. Okay, so I'm going to go 40 degrees, which is, if this is 45, then it's, you know, 2/3 of the way to 45, 40, and then with a radius of 2. So 1, 2, so that puts me like right in there. Not quite on either one, but closer to the 45 than the 30. So that would be point F. As far as G goes, we got to go 300 degrees and negative 3.5. So 300 degrees. So 300 degrees is right here. So I go 300 degrees, but then negative 3.5 means negative radius. So I pop across the pole and go 1, 2, 3.5. So that would be the coordinate point G. Okay? And then this one, negative 8 pi over 3 and negative 4. So my radius is negative 4 and my angle is negative 8 pi over 3. 8 pi over 3 is outside of the window. So negative 8 pi over 3. What I want to do is add a rotation. I want to go, so I've gone backwards over a full rotation. I want to know how much am I actually just going. So if I add a rotation back to it, 2 pi is the same thing as 6 pi over 3, right? So multiply top and bottom by 3. So that puts me at negative 2 pi over 3. So I might as well be at negative 2/3 pi, which that's going to be equivalent to this, right? So 2/3 pi is right here, right? So negative 2/3 pi is right here. Okay. And then it says negative 4, which means, that's funny, that puts me right back where A is, because if I go negative 2/3 pi, because that's going backwards 6 pi over 3 plus another 2/3 pi, and then backwards, or across the pole 4, 1, 2, 3, 4, that is also my coordinate point for H. Okay, kind of left this out there. Oh well. Alright, so those are some points. I want to see if we want to graph any more. I might as well. Okay, if you want to, go ahead and write those down. If you don't want, if you're like, I'm solid, then you can move on. That would make these H, I, J, K, L. Okay. So skip ahead if you're like, I don't need to. Okay. Let's see where those would be. Negative 5 fourths pi. 6. Oh well. 5 fourths is right here. So negative 5 fourths, right? This is 5 fourths. Negative 5 fourths would put me right here. So it's going, 5 fourths is a full half circle plus another quarter. So we're going to go, well, quarter of a pi. Okay, so I'm going to go backwards plus another quarter, which puts me here, and then 6, so 6 would be like out here. So that will be I. And then 11 pi over 6 is right here. And then, yeah. But then a radius of negative 2 pops me across the pole. So 1, 2. And that would be J. Negative 540 degrees. So this is backwards more than one rotation. So I'm going to add 360. So what's that? 180? Negative 180 degrees? Yeah? Yeah. Okay. So going backwards 180 degrees just puts me at the same thing as positive 180 degrees, but then negative 5.5 puts me, so if this is 6, so negative 180 degrees, but then go across the pole 5.5. 1, 2, 3, 4, 5.5. So that would put me right there for coordinate point K. And then negative 4, 8 pi over 9. So 8 pi over 9. You can always think of the ninths as every 20 degrees, because there are not 180 divided by 9 is 20, so 8/20s you could say, and that is 160 degrees. So 160 degrees is somewhere in here. Let's see. Yeah, 90, 20, 160, 180, 150, so it'd be, yeah. Okay, so 160 degrees, and then negative 4. So that would put me at 20 away from here, so it's kind of in this region, and that would be 4 out, so that would put me right there, and that would be L. Okay, cool. So that's just, can you given an R and given a radius and an angle, can you graph the coordinate points? And like I said, I always do the angle and then I do the radius. Makes it easier for myself. Now what we can get into is multiple representations. I think I'll go ahead and end the video, the first video right here, and then I'll jump back in on this.